Okay, so this video is about reflecting a point over any sort of line, no matter what the slope is, what the angle is, anything like that. So let's say I start off with a line of y equals negative 2x, and I have a point of 3, 1 on my graph. So I already have my negative 2x drawn here, and then my point of 3, 1 will be here, and I'll label that with an A. Okay. Now, remember, whenever something is reflected across a line, okay, that line is the perpendicular bisector. Okay, so it's important for me to find out what line is perpendicular to this line that is reflecting across. So to find a line that's perpendicular, I need something with a perpendicular slope. So if my original slope is -2, remember perpendicular lines will be negative reciprocals. So that would be positive 1/2 x. Okay. And I know that this line segment, I want it to go through my point A. So I need it to go through 3, 1. So I can plug in 3, 1 into my new equation. So then this would be 1 equals 3 halves plus b. Okay, and I can subtract 3 halves, and so I'll get negative 1/2 equals b. So then I know that my equation will be y equals 1/2 x minus 1/2. Okay, so I know that this line right here will go through my point, and it will be perpendicular to this line that goes through that I'm reflecting over. Okay, so we can go ahead and graph this line. So I'm going to go down 1/2 is going to be my y-intercept, and then I'm going to go up 1/2. Okay, up 1/2, and I can go ahead and connect the dots here. Okay, so my point is going to be on this pencil line here. Okay, and if I measured, I'll just use my pencil here. It's about where the metal ends, so it should be around here somewhere. Okay, that's a general idea of where it should be, but we need to find the exact point. Okay, so this is where that formula comes in handy, our midpoint formula. And remember what our midpoint formula is. Okay, so we have x1 plus x2 divided by 2 equals our midpoint. And the same with our y's. y1 plus y2 over 2 equals y. Okay. And so now, one other thing I need to do is I need to find my midpoint, because so far I have my x2, which is here, and my y2, which is here, but I don't have my midpoint. But I have the equations of both lines, and remember, to find where two lines meet, I just set them equal to each other. So I have y equals negative 2x right there, and I can set that equal to my new perpendicular equation, which is 1/2 x minus 1/2, and now I can solve. Okay, so this is going to be negative 4/2 x equals 1/2 x minus 1/2. I can subtract 1/2 x from both sides. Okay, and I'll have negative 5/2 x equals negative 1/2. I can multiply by the negative reciprocal here. Okay, so I'll be left with x equals, I can cross reduce, and I can be left with 1/5. Okay, so my x value where they cross is 1/5, and I can plug this 1/5 back into my equation. The easiest one will probably be my negative 2x, so I can say y equals negative 2 times 1/5, so y equals negative 2/5. Okay, so based off of that, my midpoint equals 1/5 and negative 2/5. Okay, so I can plug that back into my midpoint formula up here. And I have 3 unknowns, but now I have 2 knowns, so it will work out. Okay, so my midpoint for my x here is 1/5, so I can plug that in up here. My y, I'll go ahead and plug it in as negative 2/5. Okay, I don't know my x1. That's what I'm trying to find, so I'll leave that there. So I have x1 plus my x2. And remember, my x2 is this point right here, which is my 3, 1. So my x coordinate would be a 3, and that is all over 2. Okay, and then over here, I just have my y1 plus my y coordinate, which is a 1 over 2. Okay, so now I'm just going to solve for x over here. And so to get rid of my denominator, I'm going to multiply both sides by 2. 2 over 1, same thing. So I have x1 plus 3 equals 2/5. Okay, and then I'm going to subtract 3 from both sides. So x1 equals 2/5 minus 3, which is the same thing as 15 over 3. So x1 will equal negative 13. That should be a 5. Negative 13 over 5. Okay. I'm going to come over here and do the same thing with my y's. So times 2 on both sides. So I'll be left with y1 plus 1 equals negative 4 over 5. Subtract 1 from both sides. Y1 equals negative 4/5 minus 5/5. So y1 equals negative 9/5. So my x1 and y1 as an ordered pair will be negative 13/5, comma, negative 9/5. And I know those are not pretty values, but I go ahead and graph them over here on my line. If we think about what's going on here, negative 13 divided by 5, okay, that's going to be between 2 and 3, okay? It's going to actually be 2 and 3/5, so negative 2.6. It's going to be about here, okay? And I'm going to go down negative 9/5, which is a little bit less than 2. Okay, so that's going to put me around right there. And it's a little shorter than my arrow's pointing to, okay? But it's pretty darn close, and it is right on that perpendicular line. So I can write that this is a prime, okay? Remember, this was 3, 1, and this is going to be negative 13/5, comma, negative 9/5. Now, not very pretty numbers there, but that just proves to me that that would have been almost impossible to figure out just by counting, trying to get to the same spot on both sides as A was. I really needed to use this formula. Okay, so let's do another example here real quick. So I have 3x plus 2 is my line, 2 is my point. Okay, so I'm going to go ahead and graph my 2, which is there. Label that A. That's 2, 2. Okay, and so once again, my first step is I need to find a perpendicular line to my line of reflection that goes through my point. So my perpendicular line will have a negative reciprocal slope, so that would be negative 1/3 x plus whatever my y-intercept is going to be. So I can go ahead and plug that in. I can go ahead and say that 2 equals negative 1/3 times 2 plus b. You can go ahead and solve this. Go ahead and add 2/3 to both sides. So my new formula is negative 1/3 x plus 2 and 2/3. Okay, 2 and 2/3 will be about, let's see here, 2 and 2/3. It's about there. And my slope is 10 over 3. You can go up 1 over 3. Okay. And you can see that it goes through my point A, which is perfect, exactly what I wanted it to do. Okay, and so next, remember, next thing I need to do is find what my midpoint is. Okay, I gotta figure out my midpoint so I can use my midpoint formula. Okay, so I set my two equations equal to each other. So I'll have 3x plus 2 equals negative 1/3 x plus 2 2/3. I'll go ahead and change that. And that'll be 6/8/3. Okay, and just solve for x. So I will add 1/3 to both sides. I will subtract 2 from both sides. Okay, so I'm going to have 3 1/3 x equals 2/3. And I'll change that to 10/3. X equals 2/3 times by the reciprocal, so I can get rid of it. And so I have x equals 2/10, which equals 1/5. Okay. Then I can plug that back in, so then I can say 3 times 1/5. Sorry about that. Okay, so I can say 3 times 1/5 plus 2. And so that will give me 3/5 plus 2, 3/5 plus 10/5, which will give me 13/5. So my midpoint is at 1/5, 13/5. And if we look at my graph, that looks about correct. So remember, 13/5 is going to be between 2 and 3. That's between 2 and 3. And 1/5 is right past 0 there. Okay, so I have my midpoint. And so I have my equation here, my x1 plus x2 over 2 equals x, and my y1 plus y2 over 2 equals y. So I can go ahead and plug in my x2, which is my 2. So I can say that x1 plus 2 over 2 equals 1/5. And I can also say that y1 plus 2 over 2 equals my 13/5. Okay. Multiply both sides by 2. X1 plus 2 equals 2/5. Subtract 2 from both sides, so I can get x1 equals 2/5 minus 10/5. So x1 equals negative 8/5. Okay. Then over here I have y1 plus 2 equals 26/5. And subtract 2 from both sides and get y1 equals 26/5 minus 10/5, or y1 equals 16/5. Okay, so when I put that as an ordered pair, I have negative 8/5, comma 16/5. Once again, not very pretty numbers, but if I come over here and graph it, I'll see that negative 8/5 is a little over 1, not quite 2, so it's going to be around here somewhere. Okay. And then 16/5 is a little bit over 3, 1/5 over 3 actually. So if I go ahead and graph it, it's going to be about right there. Once again, right on my line, and that point is negative 8/5, 16/5. So once again, this just goes to prove that it's going to be really difficult, unlike when I reflect something over an axis or y equals x, something like that, where I can kind of just look at it and tell what's going on. I can count to get my answer. In this case, it's pretty impossible just to look at my graph and count spots. Okay, I really need to use this formula, and I have to start by getting a perpendicular line and then use my midpoint formula to figure out where my other point is. So go ahead and rewatch this video if you need to, and we will work on this when we get to class on Tuesday. Have a great week.